Lesson 6.2 is about radicals and rational exponents. So radicals are the inverse of exponents. Just like addition and subtraction are inverse operations, they can undo each other. And multiplication and division are inverse operations, they can undo each other. If we're going to have exponents, we should have a way to undo an exponent. So that's what radicals or square roots are for. So exponents are an easier idea. It's just multiplying a number by itself as many times as the exponent tells you. Roots are a little bit more complicated to describe. It's like the opposite of exponents. Instead of multiplying a number up, we're finding a number that would multiply up into our number. So the description I have is how many times a number has to be multiplied together to get the number the root is on. It's a confusing description, but hopefully playing around with it a little bit will make it make more sense to us. So there's really only two roots that have special names, the square root and the cube root, because squares are two-dimensional, cubes are three-dimensional. So that's where those names come from. And then anything past that we just call by the number. So this would be the fourth root. So here's our first actual example of this. A root of 3 would look like this. So here's one little fun fact. Always full of fun facts. Negative numbers, negatives, can only have odd roots if we're looking for real numbers. There is such thing as imaginary numbers, but we're not there yet. So the reason that's the case is if I do a negative times a negative, I'm going to get a positive. Then if I do that positive times a negative again, that's 3 multiplications, I'll be back to a negative. If I do it a fourth time, now it's a negative times a negative again. So any even number root or exponent has to give you a positive result if you're looking for a real number. So try not to get tripped up. If you see a negative number with an even root, we're going to have no real answer. So anyway, the thinking behind this, in this unit, we're only going to think in terms of whole numbers or integers. You won't be able to do this in your head with decimals. It's just not really a mental math thing. So anytime I ask a question like this, it's going to be, let's try and do some mental math. So 1 times 1 times 1, a root where the number is 1 is always going to give us a result of 1. That's not this situation. 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. Well, that's not 27. So we'll keep trying higher numbers. 3 times 3 times 3. 3 times 3 is 9, so 9 times 3. 9 times 3 is 27. But we wanted a negative 27. So what if these are all negative 3's? Well, now I have positive 9 times negative 3, which is negative 27. So our root is negative 3. This root number here tells us how many times to multiply. So what we needed to do was find something times something times something that equaled negative 27. We tried numbers starting at 1 and worked our way up. You'll find that these ramp up really quick. So if I go to 4, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. So they get up there pretty quick. So if it's a smaller number like this, you're going to be working in the world of smaller numbers like 2, 3, or 4. So this is the idea of what a root is if it's a root of 3, I need to find 3 numbers multiplied together to get that number. Remember what I just talked about, where these things are going to ramp up pretty quick? Well, now we have a root of 4, and 16 is smaller than 27, so it's got to be a number less than 3. So this is kind of the thinking we should go through. So I have 4 numbers multiplied together that are supposed to get 16. 3 times 3 times 3 times 3 is going to be way too big because only 3 threes is already 27. So we got to go smaller. 1 times 1 times 1 times 1 is always just going to be 1. So my guess is it's going to be 2. Let's check our work quick. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 is the 4th root of 16. So the way I would write that out is the 4th root of 16 equals 2. This is the most common way you'll see these roots written. You won't often see a problem that looks like this. That's not actually a common way to ask these questions. Here's another way to represent roots inside of exponents. So a square root is a root of 2. So we have a denominator of 2 in our exponent. In this one, the denominator is 2, but there's also a 3 in the numerator. So if we leave 2 cubed, we can represent the root separately. It's still going to be a root of 2 because the denominator is 2. Then over here, this is a root of 3. The denominator is 3. So it's just another way of representing the same information. Here we've got a few things to try. This first one is our normal cubed root. So something times something times something equals -8. This is going to be a -2. We got to get a negative number, so we have to use a negative for our root. This is +4 times -2, and those come out to -8. So we would write our final answer as cubed root of -8 equals -2. We move over one. It looks very similar, but it's just ever so slightly different. We start here. We're going to find 3 numbers that multiply up to 8. And it's going to be 2, 2, and 2, this time positive 2's. But there's a negative in front. So cubed root of 8 is 2, but negative cubed root of 8 is -2. So it's just a weird little difference between these two. They have the same answer, but technically the work you're supposed to show is just a little bit different. 16, this is one we've done before already. This is the same as the 4th root of 16. So we're going to do blank times blank times blank times blank equals 16. And we've already done this one. It's going to be 2. And finally, we get our first no solution. The reason I'm going to say no real answer is because this can't happen. If I try -2, it just doesn't work. -2 times -2 is 4, times -2 is -8, times -2 is +16. We can't actually do this one. No real answer. So there's our first, I don't really want to call it a trick question because I'm preparing you for it, but there's our first that doesn't have an actual solution. We can't evaluate it.